Module 3, problem number 11. A nutritionist wants to determine how much time nationally people spend eating and drinking. Suppose for a random sample of 952 people aged 15 or older, the mean amount of time spent eating or drinking per day is 1.28 hours with a standard deviation of 0.58. Complete parts A through D below. I'm going to focus on part C, just since you mentioned that you had a hard time with the lower and upper limits using the T distribution. So we're just going to focus on that. And if you have other questions about other parts, let me know. First, let's go ahead and write down what we know right now. Let's see if we can move that up. There we go. All right, so we know that we have N is equal to 952. Then we have the mean, the sample mean, that's X bar is equal to 1.28. Remember, we don't know the population mean. We are trying to estimate that. We only have the sample mean. And our standard deviation, or S, again, that's the sample standard deviation is S. Remember, for the population, we have mu and sigma. But since we're just dealing with the sample, that's X bar and S. So the standard deviation for that sample is 0.58. So part C here is determine parts A and B just go through the requirements of the normal distribution and that the sample must be less than 5% of the population. They talk about that. Again, if you have questions about that, let me know. Part C says determine and interpret a 90% confidence interval for the mean amount of time Americans aged 15 or older spend eating and drinking each day. So before we start talking about the interpretation, let's first go ahead and look at how to find the lower and upper limits. So I personally really like the PDF lessons I put together. This is, for me, a really handy reference sheet, and I like reference sheets with a little bit of explanation, and I think they're a great learning tool. So here's from that lesson, the purple boxes give you the formula. So right here we have the lower bound and the upper bound. So I'm going to write these over here so we've got them. So our lower bound is going to equal X bar minus, we have T alpha over 2 times S over the square root of N. And upper is going to equal the same thing but plus, right? We're going to add. So our X bar is in the middle of that confidence interval. All right. So the first thing we need to do is find that T alpha over 2 because we already know X bar, we know S, and we know N. So we just need to find that T alpha over 2. There's two ways to do this. You can either go to the T distribution table or you can do it in StatCrunch. So let's look real quick at the T distribution. So here's the T distribution table. There's a couple of things to think about with this. So first, we need to know what our degrees of freedom are. So remember our degrees of freedom, and I'll show you on here. So the degrees of freedom equal n minus 1. So in this case, that's 952 minus 1, which is equal to 951. Also, our alpha is up here. This is alpha, or basically the area in the right of the tail. But remember, we're looking for alpha over 2. So in our case, since we have a 90% confidence interval, that means that our alpha is 0.1. So alpha over 2 is 0.05. So that means we're going to be looking at this column and going down. So we're going to go all the way down until we find 951. Oops, I skipped to the next table. Sorry. Well, but here's the problem. Let me make sure I'm on the right row. This is the row we need. Here's the problem, though. As you'll notice, it goes from 100 to 1,000. Now, I will say this, 951 is extremely close to 1,000, especially when you see how small the difference is between the degrees of freedom 100 and degrees of freedom 1,000. So you can use this number, this 1.646. I'm going to go ahead and write that. T alpha over 2 equals 1.646. The other way to do this is in StatCrunch. I already did it here, but let me show you how to do it. You go to Stat Calculator, you go all the way down to T, and we're looking at standard. This this one's kind of weird. It shows it to the left, but that's okay. Remember, it's symmetric. So whatever it shows on the negative, we're just going to take the positive. So our degrees of freedom is 951. And remember, we're looking for it to be 0.05 over here. So that gives us, it says it's negative 1.6464, keeps going on and on. Remember though, we just take the positive because it doesn't matter since it's symmetric. And that means that it's the same on the negative side as it is the positive side. And if you have a little confusion there, that's fine. Let me know and I can dig in a little deeper there. But as we saw from the table over here, it's 1.646, and here we have 1.646. So they agree. So that's going to be our T alpha over 2. So now we need to plug those numbers in for our lower. I'm going to actually write that up here, 1 point, just so we've got it up here, because I have a small little tablet I'm trying to work with on here. So that means for our lower, and I'm just going to plug the numbers in. So we have X bar here. So that's 1.28 minus our T alpha over 2 is 1.646. And our S is 0.58. And our N is 952. And we're taking the square root. Now I'm going to just plug that into my calculator. And we get, and it says here in our problem to round to 3 decimals. I remember seeing that over here. Yeah, round to 3 decimals. And so we get, let me move this over also so you can see a little bit better. Sorry about that. We have 1.249. So that's our lower limit. Our upper limit is going to equal the same thing, except now we're adding that second part of it, right? So we have 1.646 times 0.58 over, again, the square root of 952. And when I type that into the calculator, we get 1.311. So just to put this in a little bit of perspective too, and I know this isn't exactly what you're asking, but I think it's helpful to consider this. Here we have our sample mean is 1.28 and our standard deviation is 0.58. So it's a pretty small variation right there, and a small number. So that this window does make sense. So we would say that we're 90% confident that the population mean is within that lower and upper bound. So if we were to go back over here and pick the one that best fits, it says the nutritionist is 90% confident that the mean amount of time spent eating or drinking per day is between, we would say 1.249 and 1.311 here. I already did check it, and those answers are correct. So I hope that helps you a little bit with the T distribution. Again, I understand that you're doing this by hand, but I cannot recommend enough, especially once you get on the final. That stack crunch is really going to help you save some time. But I do agree, you should know how to do it by hand and practice it a couple of times. But once you do understand what goes into the calculations, I do recommend using StatCrunch or some kind of tool. It's just so much easier because look, we could have done that. Let me see if I can pull it back up. Because you can also just do this. You go to Stat, T-Stats, one sample with summary, and you just put in your numbers. So we have 1.28, the sample mean. The sample standard deviation is 0.58. Sample size is 952, and you click compute and it gives you, oops, I just realized hold on. Forgot to click confidence interval. 90%, see there, everyone makes mistakes. Here we get now these lower and upper limits, and that was so much simpler. There's no calculations and no room for error. So yeah, if you have any questions about that one, let me know.